Okay, this is the Unit 2 test study guide. So starting with topic number 1, we've got relations and functions. So first set of instructions, we are finding domain and range and then determining if the relation is a function. Okay, so we've got a couple different types. We've got the finite and then the infinite or discrete and continuous that we're looking at. So these first two are discrete, meaning they just have a finite list of x values and y values. So for the domain, you would literally just list them out. So you've got all of the possible x values, put them in numerical order. So if you look down this column, we've got just 5, 6, 7, and 8. And then you actually have the exact same list for the y values. So we just write those out in this set notation like this. Asking if it's a function, remember a function essentially means that there are no repeating x values. And if you look, there are no repeating x values, so this would in fact be a function. Okay, something very similar with number 2. The domain is all of the possible x values, so you list those all out, and they're already in numerical order, so that's helpful. And then list out all of the possible y values, which are also in numerical order. Okay, like that. A function, no repeating x values. So when you're looking at it in the arrow form here, you want to make sure that only one arrow is coming out of each x value. This is fine. This does not make it a function. Or, I'm sorry, doesn't make it not a function. It just means that it's not one-to-one because of this double arrow here. But it is still a function. Okay, next we've got a more infinite set, the continuous set right here. So this, the domain, you are looking at the x values. So you're going from left to right. This time you're going to list it as an entire set of values. So you say x values such that, and then we list them. So this is our starting x value. This is our ending x value. This value is negative 1, 2, 3, 4. And it's got a closed dot there, so we include it. And then it goes up to this point has an x value of 1, but it's an open circle, so we just do a strictly less than. Okay, so that would be your first. For the range, you're doing something very similar. That was terrible, except it's the y value. Wow. We are looking at these y values, so from the lowest one to the highest one. So this lowest point is open, and it has a y value of negative 3. So negative 3. Open inequality, and then it goes up to this highest y value, and this y value is 5, and it is closed. Okay, so that's your domain and range. Function, if you're looking at a graph like this, remember it means it needs to pass the vertical line test. So if you were to pass a pen through, there's never a point where it intersects more than once. So yes, this is a function. Okay, next set, we're doing something very similar, looking at these x values and y values. These ones, since it's not discrete, we list them in the same notation as we did here. If you look at these x values, it ends at this point on the left, and then there are arrows going off to the right. So instead of a 3-piece inequality like this, it would just be a 2-piece. And you say that the starting x value is negative 3, and it just goes up from there. So x values are anything greater than or equal to, because this isn't an open circle, so it does include the negative 3. And then the range, if you look down and up, this arrow keeps going down, this arrow keeps going up. There are no breaks or gaps in the middle. So for the range, you would say that the y values will eventually hit everything if you expand the graph. Is it a function? Look at the vertical line test. You can see right here that any point except the first point, we'd be crossing through 2 points of the graph. So this one is not a function. It fails the vertical line test. All right, next set down here, 5 through 10, we've got 3 different functions. We have f of x, g of x, and h of x, and we're doing basically every different thing that we can do with this function notation, plugging in numbers, plugging in expressions, all sorts of good things here. So lots of evaluating functions. So you have a couple things that you need to keep in mind here. First, whatever letter is on the outside, either g or f or h, or some combination like this one, that tells you what function you're starting with, and then whatever's in parentheses tells you what to replace the x with. So g of negative 5 means we are using this function right here, and we are replacing each of the x's with negative 5. So x squared would be negative 5 squared, minus 8x would be minus 8 times negative 5, and then plus 21. So you can see it's identical, you're just subbing in values. So this would be a positive 25 minus negative 40 plus 21, and you plug those values in, add them all together. 25 plus 40 plus 21 ends up being 86. Okay, and then we've got 5 more of these. So this one, f of 11/12. The f is the function that we use. That's this one right here. 11/12 is what we replace the x with. So -4, replace the x with 11/12, and then plus 1. So this one's going to be a little bit tricky because it's a fraction that doesn't reduce to a whole number. So 4/12 you can reduce down to 1/3. And then this, so you end up with a -11/3 plus 1. But instead of plus 1, I'm going to write 3/3. And then that way they have a common denominator and you'll be able to add them together. So when you do that, you end up with -8/3 as your final answer. Number 7, we've got a combination of 2 of them. So we're going to do h of 8 minus f of -7. So you want to be really careful that when you evaluate h of 8, that you're kind of keeping it completely separate from the number that you get from f of -7, and then you can subtract them. So let's do h of 8 first, then we'll do f of -7, and then we'll subtract them. So h of 8, this is function h. We're going to replace this x with an 8, so absolute value, 9 minus 3 times 8. So within the grouping symbols here, we're going to first multiply the 3 times 8, and that gives us 24. And then subtract the 9 minus 24, and that gives us a -15, so absolute value would be +15. So that's h of 8. F of -7, we'll use function f and replace the x with a -7. So -4 times -7 plus 1. So this, when I do the multiplication, I get 28, and then plus 1. So that gives me 29. So that's the 2 separate values. And then for my answer, I'm supposed to be subtracting them. So 15 minus 29 ends up giving me for my final answer a -14. Okay, number 8, we have an expression to sub in, and you guys could definitely see something like this. So it's no different than what I did with this one. When I went into G and I replaced each x with a -5, I'm still using this exact same format. I'm just replacing the x's with x plus 4's, just like I replaced them with -5's here. So x plus 4 squared minus 8 times x plus 4 plus 21. Okay, so we know the pattern for a perfect square trinomial. So when I factor that out, I get x squared, and then 4x and 4x is 8x, and 4 times 4 is 16. Then take this -8 and distribute to these 2 terms right here. And then I still have that plus 21. So my final answer, I get it in standard form. I combine my like terms. I have just the 1x squared, and then when I go to combine my x's, the positive 8x and negative 8x actually cancel out. And then I have 16 and 21, and then minus 32. So those values all together just end up being 5. Okay, these two, 9 and 10, are a slightly different version of this type of problem. This one, you're solving an equation. So this says f of x equals 53. So this is f of x. We want to set it equal to 53. So it basically just turns into solving an equation like that. All right, so we would subtract the 1 from both sides. So when I subtract the 1 here, it disappears. When I subtract 1 from 53, I get 52. And then I would just divide both sides of the equation by a -4. So here it's just x, and then 52 divided by -4 ends up being a -13. All right, and then one last one from this section, number 10, we're setting h of x equal to 39. This one's going to be a little bit more complex because it's an absolute value equation. So you can think back to our last unit when we did absolute value stuff. We used the KISS method, our 2 scenarios that we're setting up. I'm thinking of the inequalities. This one, you just set up the 2 scenarios, set the inside equal to the positive version, and set the inside equal to the negative version of the number on the outside. So ignore what I said about the KISS. That is just for the inequalities. So these are now just 2 separate equations that you'd have to solve. So here you're going to subtract the 9 from both sides. 39 minus 9 is just 30. And then divide both sides of the equation by -3. negative 30 divided by negative 3 is negative 10. And this one, do the exact same 2 steps. Subtract 9. Negative 39 minus 9 gives us a negative 48. And divide both sides by that negative 3. So negative 48 divided by negative 3 gives us a positive 16. So we have 2 different values here, 2 solutions. So we have x equals, in numerical order, we have negative 10 and positive 16. All right, so that's the last one from that set, that topic. So moving on the next page to topic number 2. We've got linear equations, slope-intercept form, standard form. So we've got a bunch of different graphs on this page right here. So first one, we are writing each equation in standard form. Just to remind you guys, standard form looks like this. We've got 3 rules. This term has to be positive. They all have to be integers, which means no decimals, no fractions. And they have to have a GCF that is only 1. In other words, they can't all be even or multiples of 3 or something like that. All right, so this one. First, start by just getting it in the proper form. That's always the first thing I'd recommend. So we're going to add 2/3 x over to the other side to join the positive y, and then that would leave the 3 by itself over here. This is positive, so that rule's good. This is a fraction, though, not an integer. So in order to turn it into an integer, I would have to multiply everything by a positive 3. Okay, so I'm going to multiply this by a positive 3, and that leaves me with 2x, y times 3, and then on the other side, 3 times 3. So now check 2 and 3 and 9 don't have a GCF other than 1, so that one is officially in standard form. All right, next one, if you look at the form, it's actually good to go already. You've got ax plus by equals c. This is a positive value, but you have fractions. So we are going to clear out these denominators. This denominator is 8. This denominator is 4. So if you multiply everything by a positive 8, that'll clear out all of your fractions. So multiply this first term by an 8. So I'm going to write down what I'm doing here. So taking the whole fraction and multiplying everything by 8, just like I multiplied that other one by 3. So this 8 times 5/8 is just a 5 in front of the x plus, and then 3/4 times 8, remember you do 8 divided by 4 is 2, times 3 is 6, and then the negative 1 times 8 just ends up being a negative 8. So 3 rules. This is positive. These are all integers, and 5, 6, and negative 8 don't have a GCF other than 1. All right, next set. These ones we are writing now in slope-intercept form and then graphing. So again, just to get the form in front of you, slope-intercept is y equals mx plus b, and then we graph them by plotting the y-intercept and then using the slope to plot a few more points. So this one, basically slope-intercept form means you want the y by itself. So here we are going to subtract the 4x from each side. So we'll have a negative 4x joining the negative 10 on the right-hand side, and then we're going to divide everything by a negative 5. Okay, so when I divide this by a negative 5, and then negative 4 divided by negative 5 is positive 4/5. Negative 10 divided by negative 5 is positive 2. So that's our equation in standard form. So we start with plotting our y-intercepts, which is at 2. So we go right up there. Remember, it's a y-intercept, not an x-intercept. That's something that's commonly mixed up. And then our slope is 4/5. So we are going to go up 4 units, and then 1, 2, 3, 4, 5. I'll do one more just by going the opposite. So instead of going up and to the right, I could also go down and to the left. Okay, so plenty of points there to get a good, accurate picture of my graph. And that is your line for number 13. Okay, we can do something very similar for number 14. This one, since the y is already on the right, you might as well leave it. So I'll start by adding the 28 over to the other side. So I have 12x plus 28 is equal to 4y. And then to get the y by itself, I would divide everything by that 4. So 12x divided by 4, 28 divided by 4, and then this y is now just by itself. So we're used to seeing, of course, the y first. So it's a good idea for your final answer to rewrite it back in that order. And then to plot, we start with a y-intercept at 7. So 1, 2, 3, 4, 5, 6, 7. And then our slope is 3, so we would be going up 3 into the right one, but I'm actually out of space to go up. So instead, I'm just going to go down 3 into the left one. and do that a couple times. Okay, so just connect the dots. And that is what your line looks like for 14. All right, 15 and 16, an example of a line that's parallel and a line that's perpendicular. So you guys could have multiple answers for something like this. The point is that the slope has to match. Okay, so we're gonna rearrange this, figure out what the slope would be, and then we can answer with just a sample. Like I said, if you guys did this on your own, you could very easily have different y-intercepts, but the point is that the slope would match. So figuring out what the slope is means getting this into slope-intercept form. So subtract the 9x, which will join the -6 on the right, and then to get y by itself, we're gonna divide everything by 6. So just a y, -9 divided by 6, reduces down to -3/2, and then -6 divided by 6 is a -1. So, like I said, the important point is the slope, or important part is the slope. So with something that's parallel, it has the exact same slope. So it starts with the -3/2 x, and then you can put absolutely whatever you want as this y-intercept. So let's say we do 4. It could be any number that you want right here. This is the important part, okay? So as long as you have this number does not matter. Perpendicular is the opposite reciprocal. So opposite means it switches to positive. Reciprocal means you flip the fraction to 2/3. And then again, any value that you want at all for this y-intercept, this is the important part. As long as you'd match, you'd get this right for number 15. Number 16, y equals -5. This is an example of a horizontal line. So something that's horizontal is parallel to anything else that's horizontal. So you could do any y equals line at all. So let's say y equals -7. Okay, so that would be your parallel line, and then perpendicular to a y equals line or a horizontal line would be a vertical line. And vertical lines are x equals lines. So x equals, again, anything at all that you want. So the important part is that this is a y equals line and this is an x equals line. The number that you actually choose could change from person to person for a problem like number 16. All right, 17 and 18, we are missing a C in there. We are looking for x and y intercepts for each line, and then we're gonna graph them. So for your x intercepts, remember your technique there is that you plug in 0 for y and then solve for x. So this y gets replaced with a 0. So first thing I do to solve for x is add 3 to both sides. And then the second thing I would do is divide both sides by that -5. So 3 divided by -5 is my x-intercept. Remember, it is an actual ordered pair. So the ordered pair would be -3/5, 0. And you just approximate when you have a grid like this. So -3/5 would be like somewhere around there, just not quite making it to -1. And second thing, our y-intercepts. You do the opposite. Instead of plugging in 0 for y, you plug in 0 for x. So you have y equals -5 times 0, and then -3. So this, with that first part being 0, this just ends up being a -3. And again, remember, your y-intercept is always an ordered pair. We know we have 0 for x, and we just found out we have -3 for y. So down 1, 2, 3, and then you would just connect the dots. Okay, we're going to do that exact same process for number 18. So our x-intercept, we plug in 0 for y, and then solve for x. So this 4 times 0 ends up just being 0. So I can add 24 to both sides. So when I add 24 to 0, and then I can divide both sides of the equation by 10. All right, so when I divide both sides by 10. Remember, dividing by 10 means that you just move the decimal place like that. Okay, so it is an ordered pair, 2.4 for x, and we already knew it was 0 for y. So this we go 1, 2, and then just estimate 2.4. Next is our y-intercepts, and for our y-intercept, we are subbing in 0 for x, like this. And then we're going to solve for y. So we end up with 4y equals -24, and then you would divide both sides of that equation by 4. So negative 24 divided by 4 is a negative 6, and we knew that the x-coordinate was 0 because that's what we subbed in, and we found that the y-coordinate was negative 6. So plot this. We got 1, 2, 3, 4, 5, 6. Okay, and then just connect the dots. Okay, next page, next topic. Moving on to topic 3, writing equations and then applications. So this we've got 2 equations where you're writing it in its slope-intercept form. And so this one, we're starting off with something called point-slope form. So you always want to begin these problems with this form, and then you eventually want to get them back into slope-intercept form, but they don't start that way. They start in this form. So we know the slope, we know this points, so we are going to sub, this is our x1, y1, and then this is our m. So these 3 values are going to get subbed into this equation. So y minus y1 is 3. Equals the slope, and then times x minus x1. So that all gets subbed in there. All right, so this, change that to plus a positive, and distribute that negative 2. And then the only thing left to do to get y by itself and get this in slope-intercept form is to add the 3 to both sides. So add the 3, and then when I add 3 to a negative 16, I get a negative 13. And that would be our slope-intercept form for this line. Very similar for number 20, except this one gives you 2 ordered pairs instead of an ordered pair and a slope. So what you do there is you would take those 2 ordered pairs and you would use them to find the slope first. All right, so our slope, remember the formula is y2 minus y1 over x2 minus x1. So y2 is 6, this y value right here, minus negative 3. Over x2 is 5 minus x1 is negative 7. So these both change to plus a positive. That gives me 12. And then I can reduce this down to 3/4 for my slope. Okay, so that's the slope. You're going to set it up still into this form, and you can choose whichever one of these points you want to choose. So it doesn't matter. Pick the first one, pick the second one. As long as everything's done correctly, you should get the right values. I'm going to stick with the positive ones, just a personal preference. So y minus the y value is 6 equals the slope, and then times x minus the x value. So do the exact same steps that I just did with number 19. So I'm going to start by distributing that 3/4. So 3/4 x minus, and then 3/4 times 5. Since 5 doesn't divide by 4, I just multiply the 3 times 5 and get 15 over 4. Okay, and then to add 6, this is going to be a little bit tricky. To add 6, I'm going to add 24 over 4. So 6 is the same as 24 over 4. I do that so that my constants have the same denominator, and then I'd be able to add them. So y is now by itself. I have 3/4 x, and my constant is this negative 15/4 that was there already, plus 6, which is equivalent to 24 over 4. So when I do that and add them together, I end up with 9/4. Like that. Okay, so now for 21 and 22, I've got a couple of examples of some story problems. So number 21 says, for commission as a realtor, Michelle earns $349 plus 3% of the purchase price for each home she helps buy or sell. If she earned $8,965 in commission on a certain home, find its purchase price. So you kind of have to work your way backwards. So we're looking for 2 things. We want the purchase price, and then we also have to figure out what her commission would be. So we can set up a little equation for that. All right, so her, well, I guess we know the commission, so we don't really need to write a variable. So let's just use P for the purchase price. So she earns $349 plus 3% of the purchase price. So remember the way percentages work? When you turn them into decimals, you move the decimal place over like that. So 3% of the purchase price, and we know that she earned $8,965. So it comes out like that. Okay, so this is kind of like the y-intercept, like the part she gets no matter what, and then this is how much she earns based on the purchase price. So we're going to subtract $349 from both sides. And these are some big values, so I'm going to show you my calculator screen. So subtracting $349, we have $89.65 minus $349. So we get $8,616. So that's how much of it must have been based off of the purchase price. And then we divide both sides of the equation by 0.3. Okay, so take that value and divide it by 0.03. So we get that. Okay, so $287,200. Okay, so that was the price of the home. All right, another story problem here. Ryan's last social studies test, there were 2 types of questions, true, false, worth 2 points each, and multiple choice worth 4 points each. If Ryan earned 86 points on the test and answered 18 multiple choice questions correctly, how many true, false questions did he answer correctly? Okay, so here's what we're gonna figure out. We've got how many true, false, and how many multiple choice. So you guys can use, let's say, we can use T, I guess, for true, false, or you could use F if you wanted to. So T is the number of true, false questions he answered correctly. We'll use M as the number of multiple choice that he got correct. Okay, so true, false are worth 2 points each. So 2 points times each one he got correct, plus, and then multiple choice are 4 points each. So 4 points times each one he got correct. And we know he earned 86 points. Okay, so initially the equation is going to look like that. They also mentioned that he earned 18 multiple choice questions correct. Okay, so we've got 2T because we don't know T yet, but we do know that 18 of these were correct. All right, so we start there. So 4 times 18, simplify that up. 4 times 18 is 72. Then we can solve for T. So subtract 72 from both sides. So these are the 86 points he got total minus the 72 points that he got from the free response questions. I'm sorry, the multiple choice questions. So this ends up being 14. So what this means is that 14 of the remaining points must have been from the true false questions. So at 2 points each, that would be 7 true false questions. All right, number 23, this one we've got an example of linear regression. So we're gonna have to use our Desmos, or you could use the graphing calculator. So I am going to pull open Desmos so I can show you guys this table. Okay, so remember you do the little plus sign, add a table, and you can start adding these values in. So 0 through 5, remember Desmos starts predicting your next move, which is nice if it follows a normal pattern. And then we have 28,500, 26,378. Make sure you are looking very carefully to make sure that these are accurate. 21,774 and 19,452. Last one, 17,991. Okay, so I would take a look at your table one last time, just double check that all of your values are entered incorrect before you do this regression. Okay, so they're good. So the next thing you're gonna do is in your second option, the equation, you are going to type in a slope-intercept form. You're gonna write y1, but instead of an equal sign, remember you go into functions and into the stat section and you use that little tilde. Okay, that's what makes your linear regression. So then you do mx plus b. So alphabet, we do M, and then the X is going to be X1 to pull the values from the table, plus B. Okay, so this is how we do our linear regression. Let me get rid of that. Okay, so now you can see our slope and then our y-intercept. So that becomes your equation, so we can write those values down. So we have y equals, the slope is negative 2161.54. That's attached to the x. And then plus our b, which is 28,437.2. All right, so those are the values that we're going to use. Okay, so now I can get my phone off the screen now that we've used those values. Now find the height of the plane after 8 minutes. So minutes would be the time, so that can get subbed in for x. So y is the height. And I would use that to sub in 8 minutes for x, like that, and then you just simplify up that expression on the right-hand side. And this is an expression that, of course, could just get subbed in right into your calculator. All right, so have negative 2161.54, multiply that by 8, plus 28,437.2. Okay, so I end up with about 11,144 and then 0.88. And make sure when it's a context like this that you're using your units. So your units here would be feet for part C. How long will it take the plane to land? So landing means an altitude of 0, like it has reached the ground. So what this means, landing means that y is equal to 0. So this time we're going to replace the y with 0, and then we'll be able to solve for x. So 0 equals negative 2161.54x. So we're going to be solving for x, plus 28,437.2. So to get that x by itself, we're going to start by subtracting this over to the left-hand side. Or I could add the x term over to the left as well. You'd get the same value either way. Okay, and then to get x by itself, you're going to divide both sides by this value. So let me show you. We have negative 28,437.2, and we divide it by negative 2161.54 to get our value. So 13, and we can round just to 2 decimal places there. So 13.15 is what we'd have as our final answer. But notice that everything here is just to the nearest minute, so approximately 13 minutes. Okay, so that was our topic number 3. Next topic, we've got some systems of equations stuff. So solving using a bunch of different methods. First method that we're going to use is solving by graphing. So this is basically just doing the same graphing stuff that we were doing on the first page. So these ones, you want to get them into their y equals mx plus b form first. So I'm going to start with this top one. So this one, I'll subtract the x over to the other side. So I have negative 2y equals negative x plus 8, and then divide both sides of the equation by a negative 2. So y is by itself. Negative x divided by negative 2 is positive 1/2 x. 8 divided by negative 2 is a negative 4. Okay, so that's my first one. So let me start by plotting that. So y-intercept is negative 4. Slope is a positive 1/2, so up 1 over 2. And remember these ones I mentioned when we were actually doing this section. You want to be super accurate when you're plotting these because you need to know an exact intersection point. So make sure that you are using this slope to fill up every inch of this graph space. So that way you can be really, really accurate with your intersection point. Okay, second graph. We're going to get this into our y equals mx plus b as well. So I'm going to add the y this time to the other side. So I have 6x equals y minus 7, and then I can add the 7 over to the other side. So 6x plus 7 is equal to y. So intercept, slope, we can plot that. So my intercept would be 7. So I have 1, 2, 3, 4, 5, 6, 7. And then my slope here is 6. So I'm out of space to go up, but I can go down 6. So 1, 2, 3, 4, 5, 6. Oh, looks like I did not go up high enough. Okay, this should be up here. Sorry about that. So I'm going to go down 6 and to the left 1. 1, 2, 3, 4, 5, 6, and to the left 1. So it hits that point right there. So that ends up being our intersection point between the two graphs. And you should have that intersection point listed as your final answer. So if you count back to this point right here, that's over negative 2 and then down to negative 5. So your actual intersection point should be your final answer for something like 24 and 25. All right, next, number 25, we're basically doing the exact same thing. So we are going to get this one, this top one, into slope-intercept by adding 6 to both sides, like that, and then you're going to divide both sides by 3. So y equals 4 divided by 3 plus 6 divided by 3. So that's the first one. We'll plot that. Y-intercept of 2, slope of 4/3, so we can go up 1, 2, 3, 4 over 3, And then I'm out of space, so I'll do the opposite. And down 1, 2, 3, 4, over 1, 2, 3. Connect the dots there. And let's do the same thing with this other one. Here, all I need to do is divide everything by 12. So 16 divided by 12, that reduces down to 4 over 3. Plus 24 divided by 12 is 2. Okay, so this one, we start at a y-intercept of 2, and you can actually see that's going to be the intersection point, but we'll finish off the rest of this. So we've got, if you look right here, actually, you see we've got the exact same lines. If you went up 4 over 3, it ends up being the exact same line. So what you would say there is you actually have an infinite number of solutions because the two of them turn out to be the exact same line. If the two lines ran parallel and they didn't ever actually intersect, that would be no solution. Okay, so 3 things could happen. 1 intersection point, every intersection point, or no intersection points. All right, next, number 26, we're going to solve by substitution. So we have a multi-step process that I had for you guys in the notes. So step 1, solve one of the equations either for x or for y. So you're always going to just pick out the one that's easiest, and I would say this x is already pretty darn close to being by itself. So we're going to rearrange that equation by subtracting the 7y. So that expression would look like that. Step 2, substitute the equation from step 1 into the other equation. Okay, so we're going to take this expression right here, and we are going to sub it in right there for x. Okay, so 5, but in place of x, we're going to put negative 6 minus 7y, because this tells me I can use that to replace x. And then finish off the rest of that first equation. Okay, so I've got the first equation, except in place of the x, I have this expression. And then you use step 3, solve for that variable. I'm sorry, we're still in step 2. So distribute that 5. Combine my like terms, so I've got these two things. And then I'm going to solve for y. So add the 30 to both sides. So 9 plus 30 is 39. And divide both sides of the equation by negative 39. So I end up with a negative 1. So that's my first value. That's my y value. Once you have that, it's pretty quick to find the other one. Because your step 4 is you substitute your answer from step 3 into either one of the equations. I would sub it in here since x is already by itself. Right? So we've got x equals negative 6 minus 7y. So you sub that in. So x equals negative 6. This ends up being plus 7, which comes out to be a positive 1. Any answer from this section should always be written in an ordered pair. So x first and then y. 27, we're also solving by substitution. So we're going to do the exact same set of steps. So step 1, solve one equation for x or y. So I'm going to get this y by itself. So first would be subtracting the 8x. And then after that, you divide everything by a negative 1 to get the y by itself. Okay, step 2, substitute that expression into the other equation. Okay, so this expression for y is going to get subbed in right here for this y in the first equation. So 2x plus 3y, but the y is getting replaced with 23 plus 8x is equal to negative 35. Okay, so step 3, solve for the remaining variables. So we only have x's here, so we can go through and solve for x. So 2x plus, and we distribute this 3 here. 3 times 23 is 69, plus 3 times 8x is 24x, equals a negative 35. So we've got a couple steps here we end up using to solve for x. So combine these, we get 26x. And then 26x, we can subtract the 69 from both sides. So negative 35 minus 69 is negative 104. And then finish it off by dividing both sides of the equation by 26. Okay, so negative 104 divided by 26, something you might want to use a calculator for, but you end up with a negative 4. And then next thing we want to do is sub this back in and solve for y. All right, so we have y equals 23 plus 8 times x. So we can sub that value in. So we get 23 minus 32, and that ends up leaving us with a -9. So ordered pair always, x first and then y. And that gives us our final answer for 27. Next to 28 and 29, we're going to solve by elimination. So you've got a step-by-step process for elimination as well. Step 1 is to line up the equations. So make sure you've got x's on top of x's, y's on top of y's. So this one I'm going to rearrange the top one a little bit. So the 3x is fine where it is. I need to subtract the 14y and then subtract the 10. Okay, so a little bit of rearranging there, so forget about that one. I lined it up like that. So that's step 1. Step 2, multiply one or both equations to get the variable with the same coefficient. Okay, so the 8 and 3 is going to be a little bit challenging, but the 7 and 14 I can make work. If I take this whole top equation right here and multiply everything by a -2, then this will be a positive 14y, which will cancel with this negative 14y. All right, so let's rewrite what we have. So this, if I multiply everything here by a -2, that is what I get. And then I'll line up the second equation right underneath it. Okay, step 3, add those equations together to eliminate this variable. So add the x's together, the y's will eliminate, and then add these together. Step 4, solve for the remaining variable. So I have -13x equals -78. I would just divide both sides by a -13. -78 divided by -13 ends up being 6. So you have one of the values right there, and then step 5 is to sub this into either equation to find the other variable. Okay, so this, I'll go into the top equation here. So 3x plus 10 equals 14y, just because that one has the y almost by itself. So 3 times 6 is 18, plus 10 is 28, and you set that equal to 14y. So divide both sides of the equation by 14. 28 divided by 14 is 2. So I've got my 2 values that I can write in as an ordered pair for my final answer. Okay, number 29, I'm doing something very similar. So I'm going to follow that exact same 5-step process. So step number 1 is to line up the equations. So make sure you've got both of them in standard form. So the top one, I have 18x, and then I need to subtract the 12y and leave the constant by itself on the right. Second one, I need to add the 12x over, leave the -8y where it is, and then I need to subtract the 21 over to the other side. So that's step 1, is just to get them all nice and lined up. Step 2, multiply one or both by a number to get the same coefficient. So this one is 18 and 12. I could make them both 36 if we wanted to. This one, 12 and 8, I could make them both 24 if we wanted to. So let's say we make the x's both 36. So I will make the top one a positive 36 by multiplying everything by 2, and I will make the bottom one a negative 36 by multiplying everything by a -3. Okay, so let's line up what we've got here. So everything in the top by 2, we get 36x minus 24y equals 7 times 2, which is 14. Bottom equation, multiply everything by a -3. So first I get a -36x. -3 times -8y is a positive 24y. And -21 times -3 is a positive 63. Okay, step 3, add those equations to eliminate the variable. So these cancel out, but then these actually also cancel out. So I end up with a 0 on the left, and then the right-hand side is 77, which of course is not true. So anytime in a situation where you're solving equations, anytime you end up with a number equals a number and it's a false statement, you would say that there is no solution to that equation. What this means visually is that they would be parallel lines that would never intersect each other. All right, we've got an application here, number 30. Ben has a collection of quarters and nickels worth $5.35. If the number of nickels is 5 less than twice the number of quarters, find the number of each coin. Okay, so we are going to use N for the number of nickels, and we'll use Q for the number of quarters. You could also always use X and Y for every single equation. Just make sure that you're labeling them. So, collection of quarters worth $5.35. So nickels are worth 5 cents each. So 5 cents per nickel plus 25 cents per quarter is worth $5.34. That's the first one. The second one is the number of nickels is, so N is 5 less than twice the number of quarters. So twice the number of quarters minus 5. All right, so a couple of options here. You could do a substitution, you could do elimination. This one is nicely set up for substitution just because one of the variables is already by itself here. So I'm going to use substitution. So I'm going to take this expression and sub it in for that N right there. So 0.05 N, but in place of N, I'm going to have 2Q minus 5 plus 0.25 times Q is equal to $5.35. So we're dealing with some decimals. You might want the assistance of a calculator here. So distribute this 0.05. So 2 times 0.05 is going to be 0.10 times Q. And then 0.05 times 5 is negative, and that'll be 0.25 when you distribute that 0.05. All right, and then plus 0.25Q equals 5.35. So combine my like terms, 0.10, 0.25 add up to 0.35Q. Don't let the decimals freak you out too much. Okay, and then add 25 cents to both sides of the equation. So add 25 cents, and this ends up being $5.60. Okay, and then the only thing left to do is divide both sides by the 35 cents. So I can show you this one in a calculator just because it might not be one you do in your head. So 5.60 divided by 35 cents, that ends up being 16. So 16 is Q, and Q, remember, is the number of quarters. So Q ends up being 16, and then we can use that to figure out the number of nickels. So the number of nickels is 5 less than twice the number of quarters. So twice the number of quarters would be 32. 5 less than that would be 27. There we go. All right, next sheet, we've got a couple more applications. So on to number 31. So you've got Aaliyah, she bought 4 composition notebooks, 3 packs of pencils from the school bookstore, and paid $10.93. Laura bought 7 composition notebooks and 2 packs of pencils and paid $13.31. Each pencil pack contains 10 pencils. What is the unit price per pencil? So we've got a lot of little details to figure out here. I just want to show you something different. Say you always want to use X and Y. You can do that too. Just make sure that you label them. So X is going to be the number of notebooks, and then Y is going to be the number of pencil packs, not just the individual number of pencils. That's something we'll find out later. Okay, so let's set up a situation for Aaliyah. So Aaliyah bought 4 composition notebooks and 3 packs of pencils and paid $10.93. Laura bought 7 composition notebooks and 2 packs of pencils and paid $13.31. So these, just by the form that they're set up in, I would recommend using the elimination method because they're set up both in standard form. So the next step for the elimination method would be to multiply the equations by a number that's going to make our values cancel out. So these are smaller. We can make them both 6s. So let's multiply everything here by a positive 2 to make that a positive 6y. We'll multiply everything here by a negative 3 to give us a negative 6y. So let's line these all up. So multiply everything by 2 in the top one. And this, when you've got decimals like that, might be a good idea to have a calculator. Okay, so $10.93 times 2 is $21.86. And then we'll do the same thing with this bottom one, multiply everything through by a -3. And then same thing here, we might want to use the calculator to multiply that by a -3. So we get -39.93. Okay, so line them up, add them together. 8x -21x is a -13x equals, and then we can combine those two values up. So 2186 minus 3993 is -1807. Okay, and then we can divide out that 13 from both sides. So divide this by a -13, and I end up with $1.39. Okay, so that's x. So x is equal to $1.39, and that would be the notebooks. So each notebook is $1.39, and then we can use that to figure out the price of the pencil pack just by plugging it into one of our equations. So let's just say we go with the top one. All right, so 4x plus 3y is equal to $10.93. So 4 times $1.39 is $5.56. Okay, when you subtract the 556, we have 1093 minus 556. That's what gets your 3y by itself. So we have $5.37. And then divide both sides of the equation by 3. So we end up with y equals $1.79. Okay, so $1.79 is the price of the entire pencil pack. So we want to know the unit price per pencil. We would finally take that and then divide that by 10. Okay, so each pencil costs, and then we would divide that by 10, which really just means moving the decimal point over. So 0.179. And I know this, obviously, you don't have 3 decimals for for money, but we'll do that anyway. They would still do that if they were talking about unit price on like a sign for a product or something like that. All right, number 32. Our last equation here is one of the ones with 3 variables. So step-by-step process here. So start with 2 equations where you can easily eliminate a variable. So I would go with these 2 right here. That one looks pretty straightforward to eliminate. You could also go with the z's. The z's are not hard to eliminate either. So we'll start with this combination. So we're going to do that. And that combination is basically just going to make them eliminate right away. Okay, so I'm going to write that combination over here, just separate it out. And I'm choosing this one just because you don't have to do any additional work at all. The y's will just cancel out right away. Okay, so those will cancel. We get 5x plus just a 1z equals 37. Okay, so we do that. Second step, eliminate the same variable from a combination of the equation you haven't used yet and then one of the ones that you did. Okay, so this combination made us equation A, and then we're going to form an equation B. So we have to use this one. Since this is a -7y, I'm going to stick with the first equation since it's positive. It really wouldn't be too much of a difference, but I am going to do that second combination of this one and this top one. All right, so if I line up the top one, and then I'll write in what I have to multiply by. Bottom one. Remember, this step, it's very important that you're eliminating the same variable that you just eliminated. So this top one, these I have to get them to be 14. So I'm going to multiply everything here by 7. I'm going to multiply everything here by 2. Okay, so we'll rewrite what we got. So everything in the top one by 7. Okay, I'm going to type that one in. 47 times 7 is 329. And then bottom one, everything by 2. So we get 18x minus 14y minus 2z. Oops, I missed my z on that one. Equals, and then 75 times 2 is 150. So line these up. We'll see what will cancel. These will cancel out. These I end up with a 46x. These I end up with a negative 37z. And then equals, and I can add these two values together and I get 479. Okay, so that one we are calling equation B. Okay, so the hardest part is over once we do those two equations. All right, so now we have equation A and equation B together, and we're going to solve that system. So this is just like a system of two equations here. So the 5x compared to 46x, that's not going to be easy. But since this is just a z, we can multiply it by 37 to get it to cancel with this z. All right, so let's do a little side work for this one. Oops, this should be a minus, sorry. All right, so we're going to take everything in this equation, multiply it by 37. So let's rewrite what we've got here. So 37 times 5 is 185x plus 37z equals, and then 37 times 37 is 1369. And then we're just lining this second one up right underneath. So remember, our values always get a little big here. That's what calculators are for. So these will eliminate. Let's add together the 185 and the 46. And that gets us 231 attached to the x. And then we can add those other two values together. And that gives us 18/48. And then divide both sides by 231 to get the x by itself. And that leaves us with 8. So we have x equals 8. That's our first value. Once you get that first value, the rest of it is not that bad at all. Okay, so this, we're going to take this value and sub this answer into one of these right here. I would definitely go with this one. So we'll do 5x plus z equals 37. So this ends up being 40. So if I subtract 40, 37 minus 40 is a -3. So now the hardest part's over. We just need to get that value for y. All right, so we can take any of the equations. Might as well just go with the top one. So sub in the x and the z that we just found and then solve for y. So 4 times x plus 2y minus 5 times z is equal to 47. So 4 times 8 plus 2y, -5 times -3 equals 47. 32 plus 15 is 47, so if I subtract 47 from both sides, then I have just a 0 on the right, and divide both sides by 2, so 0 divided by 2 is 0. So make sure for your final answer you're writing your solution as an ordered triple. All right, so an ordered triple would be the x, then the y, and then the z. Okay, we're down to just 5 problems here. On to topic number 5, linear inequalities and systems of linear inequalities. So this first one, we're doing basically just a y equals mx plus b graph. So our y-intercept here is 3. Our slope is -7/2. So we can go down 1, 2, 3, 4, 5, 6, 7, and to the right 2. So at this point, 2 points is plenty. Take a look at your inequality. It's just a greater than. So since it's just a greater than, we would be plotting a dotted line. And then 2 options, greater than versus less than. Since it's a greater than, we shade above. So even though it's pretty slanted, the above would be this direction right here. All right, 34, we can do the same thing, except this one wasn't given to us in y equals mx plus b, so we have to turn it into that form first. So I'm going to subtract the 2x from both sides. So I'll have a -2x joining the 36. And then next step would be to divide both sides by that -6. So the y is by itself. When I divide by a negative, it's going to flip my inequality symbol. Don't forget about that. -2 divided by -6 is positive 1/3. And 36 divided by -6 is a -6. So that's now in our slope-intercept form. So we'll be able to plot that. So y-intercept of -6. 1, 2, 3, 4, 5, 6. Slope is 1/3, so I can go up 1 to the right 3, up 1 to the right 3. And then my inequality tells me 2 things. It tells me about the line and it tells me where I shade. So since it has the or equal to, it's going to be a solid line. And a less than means that I shade underneath. Okay, so that would be that second inequality. All right, on to our last page. So we've got a couple more inequalities here for 35 and 36. so for this one, the top one needs to get put again into slope-intercept form. So I'll start by subtracting 5x from both sides. So negative 5x joins the negative 8s, and then divide both sides of the equation by negative 2. So the y ends up by itself. Dividing by a negative makes me flip my symbol. Negative 5 divided by a negative 2 is a positive 5/2, and negative 8 divided by a negative 2 is a positive 4. Okay, so let's start with our y-intercept at positive 4, and then the slope is 5/2. So I run out of space this way, but I could go down 5 and to the left 2 to get my point. It's a less than, not or equal to, so I have a dashed line, and then the less than part of it means that I would be shading down. Okay, and then this is a system, so I have 2. All right, so this other one, y is less than or equal to negative 3. If it's just a y and I don't have an x, remember that makes it a horizontal line. So I go to my y value of negative 3, and I'm just going to extend it as a horizontal line. Pay attention to the inequality. It is less than or equal to. So it's going to be a solid line like this. Less than for a horizontal goes underneath it. So I would shade underneath. So do something, make this part darker somehow. We could put a big S in it to make that the solution set. So that would be what the actual set looks like for 35. Let's do something very similar for number 36. Top one, we need to subtract the x from both sides. So we have negative y is less than or equal to, I have a negative x joining the positive 4. And then with this one, again, divide everything by a negative 1. So this is now a y. Dividing by the negative flipped my sign. This one's positive, this one's negative. So x minus 4, I would go down to this is my y-intercept, and then I should have a slope of 1. So in front of the x, there's technically, a 1 there. So I can go up 1 to the right 1, up 1 to the right 1. And you, of course, could extend that for a while, but this will be enough to show the shape of our graph. So greater than or equal to means solid line, shaded above. So start with just kind of a light shading there because that's only half of it. Second part is this one right here. All we need to do to get the y by itself is to divide both sides by 3. So the y is by itself. This does not flip the inequality this time because it's a positive. 3x divided by 3 and 9 divided by 3. All right, so this one, the y-intercept this time is at 3. And then my slope again is technically just a 1. So up and to the right, up and to the right. And this one, greater than or equal to, is a solid line shaded above. Okay, so this one's shaded above. So it actually just kind of overlaps a big part of what this one was. So make this extra dark. This is our solution set. Okay, and we are down to our last one right here, number 37. We're going to write our own system of equations and then use it to come up with some combinations. All right, so Kayla's got an exercise program. She either runs 6 miles a day or rides her bike 10 miles a day. Her new goal is to cover a minimum distance of 200 miles with at least 15 days running. Okay, so she would like to determine the number of days it would take to accomplish this. That's what we can figure out. So a system of linear inequalities. So let's do x is the miles running and y will be the miles biked. Okay, so first thing is she wants to do a minimum distance of 200 miles. So 6 miles running combined with 10 miles biking, we want it to be a minimum of 200. So that would be set up like that. At least 15 days running. So we want the running, sorry, this wouldn't be miles. These would both be days. Okay, so this one, then you multiply by the miles. So we want at least 15 days running. So you set up like that. Okay, so then we're going to graph it. So graphing would mean putting that top one into slope-intercept form. So this top one, we'll do a little side work. So subtract the 6x from both sides. So that would be a negative 6x over on the right. And then divide both sides by 10. So the y ends up by itself. Negative 6 over 10 reduces down to negative 3/5. and then 200 divided by 10 would be 20. So you can see I extended this a little bit, but we're still going to want to scale. So let's make each one of these boxes 2. So to plot this, we would go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so we do that, and then our slope would be a -3/5. So that's a little bit tricky to do, but -3/5 is the same as -6/10. So since it's hard to go down 3 and over 5, we could just go down 6 and over 10. So down 2, 4, 6, over to the right, 2, 4, 6, 8, 10. Do that a couple times. Okay, so we get that set up. So greater than or equal to this line right here. So the or equal to makes it solid. The greater than makes us shade above. And then the second one, we want x to be greater than or equal to 15. So we can scale this one as well by 2. So 2, 4, 6, 8, 10, 12, 14, 16. So 15 would be right in the middle there. Greater than or equal to. So the or equal to makes it solid, and then greater than takes us out to the right here. Okay, so this part, that's our solution set where these two overlap. And the last little piece here, part B, using your graph, give 2 possible combinations of days Kayla can run and ride her bike to meet her goal. All right, so you could take really just any ordered pair that's in this solution set right here. So let's take, whatever this point is right here. Okay, so this, if we trace down here, this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then it's up at 2, 4, 6, 8, 10, 12, 14. Okay, so 20 and 14. That is the same as 20 days running. Plus 14 days biking. And then literally any other ordered pair. So let's see, maybe this one. So this one is 2, 4, 6, 8, 10, 12, 16, 28 for X. And then it's actually only up at 4 for Y. So this combination would be 28 days running plus just 4 days biking. So you do those two things and she meets her goal of 200 miles, and she also meets her goal of at least 15 days running.